Baking soda is one of those things we all have in our kitchen, right? It's small, white, powdery, and works like magic in baking. But here's the twist. It's not just for fluffy pancakes or soft cookies. It's used in cleaning, deodorizing, personal care, and even in factories. While we use it so casually at home, the process of actually making it is a complex science involving heat, pressure, and precise chemistry. Most baking soda we buy is made in large factories using something called the Solvay process. It's named after a Belgian chemist, Ernest Solvay, who came up with it in the 1860s. This method is super popular, and it's still used today around the world. It's efficient, cost-effective, and smartly designed to reduce waste. Let's walk through each step and see how regular ingredients like salt and limestone are transformed into the baking soda you use every day. Step 1. Making the brine. Everything starts with a salty solution called brine. And no, this isn't the brine you soak your pickles in. This brine is made by mixing industrial-grade salt, basically purified table salt, into hot, clean water. The water needs to be super pure because any impurity can mess up the chemical reactions that come later. Factories often use filtration systems to make sure the water is spotless. Once the salt is added, the solution is stirred continuously. The goal is to dissolve as much as salt as possible into the water, turning it into a thick, salty liquid. After mixing, the brine is cooled down to just the right temperature. This part might sound simple, but it's actually super important. Cooling prepares the brine for upcoming reactions and helps the next steps go smoothly. Step 2. Creating soda ash. This is where the real chemistry begins. Factories take a natural rock called limestone, which contains something called calcium carbonate, and crush it into tiny pieces. This limestone is then heated at very high temperatures. We're talking over 850 degrees Celsius, which is more than 1,500 degrees Fahrenheit. The crushed limestone is then mixed with salty brine from step 1 inside large industrial towers called Solvay towers. These towers are like huge high-pressure ovens where chemical reactions happen. When heat is applied and everything's mixed together, a key reaction occurs. The salt and limestone interact to produce sodium carbonate, also known as soda ash. This is a major ingredient in baking soda. A byproduct of the step is calcium chloride, which isn't thrown away. It's reused for de-icing roads and controlling dust, so nothing goes to waste. Step 3. Filtering the solution. After that intense reaction inside the tower, the result is a mix of soda ash, calcium chloride, and water. But it's not neat or clean. It's a soupy mess that needs to be filtered. This step is just like sifting flour to remove lumps. Factories use giant filtration systems to remove any solid leftovers, mainly by the calcium chloride from the liquid. What's left is clear soda ash solution that's now ready to be transformed into baking soda. During this step, quality control is super important. Factory workers test the solution to make sure it has the right strength and chemical balance. If it's off by even a little bit, the final baking soda might not work well. And nobody wants baking soda that can't rise a cake or clean your fridge. Step 4. Making baking soda. Here comes the transformation. The soda ash solution is now combined with ammonia gas and carbon dioxide. This causes another chemical reaction that creates sodium bicarbonate, the scientific name for baking soda. During the reaction, solid particles of baking soda begin to form, kind of like tiny crystals growing in a snow globe. These crystals slowly sink to the bottom of large tanks, separating themselves from the rest of the liquid. At this point, baking soda has officially formed, but it's not quite ready yet. The solid particles need to be collected, dried, and refined. The reaction also creates ammonium chloride, another useful chemical, which is separated and reused in other industries. It's all very efficient. Almost nothing gets wasted in this whole setup. Step 5. Evaporation and crystallization. Now we've got baking soda particles, but they're still wet and mixed with unwanted liquid. So what happens next? Evaporation. The wet mixture is gently heated to slowly remove all the water. This step has to be carefully controlled. If the heat is too high, the baking soda might break down or lose its properties. As the mixture cools again, the remaining liquid becomes saturated, and beautiful little baking soda crystals begin to form. These crystals are exactly what you see when you open a box at home: white, fine, and slightly sparkly. Once they've formed, they're separated from the leftover water and prepared for drying. These crystals are the purest form of baking soda and are super versatile, whether you're baking cookies or cleaning your bathtub. Step 6. Drying and sizing. At this stage, the crystals are formed but still hold a little moisture. To make sure the final product is shelf stable, the crystals are thoroughly dried. This is done using vacuum dryers, which are special machines that remove water without using very high temperatures. The vacuum sucks out moisture gently, keeping the crystals perfectly intact. Once dry, the crystals are sorted by size. Different applications need different sizes. For example, the baking soda used in toothpaste or deodorant needs finer grains than the one used in industrial cleaners. Special machines use air jets, filters, or screens to separate the crystals into categories. It's almost like sorting gemstones. Precision matters. This step ensures every box or bag of baking soda has a consistent texture, so it works the same way every time you use it. Step 7. Packaging the final product. Now comes the final step: packing the baking soda so it can head to store shelves in homes around the world. Machines weigh the right amount of baking soda and fill it into cardboard boxes, plastic pouches, or even industrial-sized sacks, depending on where it's going. It's all done with high-speed automation to keep things clean, fast, and efficient. The packaging isn't just about looks. It's designed to protect the baking soda from moisture and air, since baking soda absorbs odors and liquids so easily. The box has to be sealed tightly. Some boxes even come with special liners or resealable tops for long-term freshness. Whether you buy a small box for your fridge or a big one for deep cleaning, every container is packed to preserve the quality of the crystals inside. While most baking soda is made using the factory method, there's another cool way it's made: by mining it straight from the earth. In certain places like Wyoming, there are huge underground deposits of a natural mineral called trona. This rock contains sodium compounds that can be turned into soda ash and eventually baking soda. Trona is mined just like coal or salt. Workers dig tunnels underground and bring the trona rock up to the surface. It's then crushed, treated with heat, and chemically processed to extract soda ash. From there, the steps are almost the same. The soda ash is converted into baking soda using carbon dioxide and ammonia. This method is considered more environmentally friendly since it skips some of the chemical reactions used in the Solvay process. Still, it depends on location and mineral availability. So now you know. That tiny white powder you use for baking, cleaning, or brushing your teeth goes through a long, detailed journey before it reaches your home. From salt and limestone to heat and chemistry, baking soda is the result of smart science and precise engineering. It's a perfect mix of nature and human creativity. Understanding how it's made gives you a whole new respect for something we often take for granted. Next time you sprinkle it into pancake batter or scrub your sink, you'll know just how much effort went into creating it. From underground rocks to bubbling factory tanks, baking soda is more than just a kitchen staple. It's a modern marvel.